Okay, here we go. Unit 5, Lesson 12. Practice problems. Number 1, give each solid a geometric name. Be as precise as you can. So as precise as you can means adjectives. Use some adjectives. Hey, English word. All right. So the base here is a hexagon because it has 1, 2, 3, 4, 5, 6 sides. It's also oblique because it's tilted, and there's an apex. So you got to ask yourself, all right, is that thing a cone or a pyramid? So this one is going to be an oblique hexagonal pyramid. All right, this one, we got a right triangle. So the base is a right triangle. And then you also have, the shape is a prism because there's no apex. I don't see like a point where all the vertices come together. So this is going to be a right triangular prism. Okay, I see an apex. I see a circle for a base. And it's tilted, so it's oblique. This one is an oblique cone. So throw some adjectives in. All right, number 2. Each set of two-dimensional shapes, so here's the 2D shapes, is the complete list. So they're listing all the faces. Those are like all the different sides of the solid. So this is the list, and you have to match which solid it is. So we have a right triangular prism, 2 congruent triangles, and 3 rectangles. That would be this one. Okay. 4 triangles and 1 rectangle. Let me think. That's looking like a pyramid to me. So yeah, rectangular pyramid. Here, I'll show you that one. So rectangular pyramid means the base is a rectangle. And you've got 1, 2, 3, 4 triangles. Okay, 2 squares and 4 congruent parallelograms. I'm thinking it's this one right here. Oblique square prism. So that would be like this. Oblique square prism. So you draw a square. Let me do another one like up here. And it's oblique, so it's like tilted. So there's an oblique square prism. So 2 squares, top and bottom, plus 4 congruent parallelograms. Okay. That means this one is number 3. 4 congruent equilateral triangles. So it's a right triangular pyramid. So imagine an apex. You got to think in 3D, but it's going to be 1 in the back plus 1, 2, 3, 4. There you go. Okay, these congruent square pyramids can be assembled into a cube. So 1, 2, 3, you assemble them into a cube. This is what we're doing with those P1, P2, P3s. With side length 1 foot. So they're talking about the cube is going to have side length 1 foot. That's where it's kind of tricky. So these are all like 1, 1, 1. And then you also know these are 1, 2, because we got a square on the bottom. Now what you learned is any of the solids we talk about that have an apex, like pyramids, the volume equals base height divided by 3. So this is our base, which is a square. And there's another one. I'm going to write it right here. Area of a square is just length times width, or side squared. So the base is 1 square foot. So the area is 1 square foot. 1 times 1, right? Then the height is also 1. So the base equals 1. The height equals 1. So you just plug these into this formula right here. So the volume of each of these, volume will equal 1 times 1 divided by 3, which equals 1/3 cubic foot. And that makes a ton of sense, because if this one's volume equals 1/3, this one's volume equals 1/3, this one's volume equals 1/3. If you add them all up, that's 3/3, which is 1 cubic foot. 1/3 plus 1/3 plus 1/3 will be 1 cubic foot. And that makes sense because we got a cube that's 1 by 1 by 1. Okay, so what is the volume of each pyramid? Represents the volume of each pyramid. What do I really want you to know on this lesson? This formula for pyramids and cones. Base height divided by 3. Okay, number 4. A prism has a height of 4 inches and a volume of 120. Select all figures that could be the base for this prism. So this one's tricky because you're like, I don't have a figure. I don't know what kind of prism they're talking about. But you know that all prisms have a volume formula. Prisms are different. They do not have an apex. So their volume formula is always just base height. So this one, your height is 4, your volume is 120 cubic inches. Select all figures that could be the base. So select all that could be the base. So what you do is you just use this formula, and you'll say 120 equals base times 4. Then you just divide by 4, divide by 4. These cancel out. 120 divided by 4 is 30. So you know the base is 30. So you're looking for any bases of 30. So a 5-inch by 6-inch rectangle, yep. 5 times 6 is 30. A square with side length 5 inches, nah, that'll give you a base of 25. Because 5 times 5 will equal 25. And that's not 30. So you skip B. A circle with radius 5 inches. I already know circles are no good because if you found the area of a circle, it's pi r squared. So pi times 5 squared. That would be 25 pi. That does not equal 30, so you gotta skip that one. How about a star-shaped base with the area at 30 square inches? That they're just trying to trick you there, but if the base is 30, then you're good. Okay, a right triangle with legs 5 and 12, so they're saying a right triangle 5 by 12. So sometimes you gotta draw yourself a picture. So 5 by 12. And then you know that area of right triangles is 1/2 base times height, BH. So that equals 1/2 12 times 5, which equals 1/2 of 60, which equals 30. So yeah, this one would work. So ADE for number 4. All right, this prism has a right triangle for a base. The volume of the prism is 54 cubic inches. Okay. What is the value of H? All right, so we know prism volume. We know that. Volume equals base times height. So we know that. We don't have the base yet, right here. The area of this triangle. So again, we don't have the area of this triangle yet. But we could easily find that because they told us that it's a right triangle. So we're just going to label this little thing B, like in Pythagorean theorem. So then you can just say, you just use Pythag, which is a squared plus b squared equals c squared, right? So you say 4 squared plus b squared equals 5 squared. 16 plus b squared equals 25. Subtract 16, subtract 16, these cancel out. B squared equals 9. B, take the square root of both sides. B equals 3. Okay, so we know this is 3, right? And then the area will equal 1/2 b times the height of the right triangle. So 1/2 the legs multiplied together. 3 times 4. So the area is going to equal 1/2 of 12, which is 6. So this area is 6, which is also known as big B. The base, right? The area of the base is 6. So now you go back to this. So volume is 54. I'm just going to write it again. V equals BH. 54 equals our base, which is 6, times our height. Divide by 6, divide by 6. These cancel out. H equals 54 divided by 6. So height equals 9. So 9 units. Pretty easy. You just got to know this formula right here, and then you just got to chip away at the area of the triangle. Pretty easy stuff. Okay, number 6. This solid has curved sides. Okie doke. I'm already thinking on this one, I'm already thinking Cavalieri's. Cavalieri's principle basically states, remember we did the stacks of quarters and then the stacks of Uno cards? So like basically a stack of quarters. So you had the same number of quarters, right? Even though we like tilted it, it was the same number of quarters, so the volume didn't change. And it basically states that like if all cross sections have the same area and the height's the same, because same stack of quarters, the height's gonna be the same because they all have the same depth, right? Every quarter has the same height, I should say. So even though we tilted the stack, the volume was the same, and that was Cavalieri's principle. So here we go. The solid has curved sides. All cross sections parallel to the base are squares measuring 3 units on each side. So you automatically know the area of this is 9 square units. And then the height from the base to the top, is 5. So all you got to do is just kind of like, if you think about the stacks of quarters, you just take the area of the cross section, multiply it by the height. So the volume will still be base height. And this one is 9 times 5. So volume is going to be 45 cubic units. And even though it's curved, we know from Cavalieri's principle that like oblique prisms will have the, as long as the area and the height's the same, they'll have the same volume. Okay, find the volume of each solid, number 7. A cylinder with radius 3 and height 2. That one's so easy. So you got this cylinder, right? Didn't really draw it to scale, but that's okay. So the radius is 3, height is 2. You know the volume of all cylinders is pi r squared times height. So you just plug those in. This is radius. So you go pi. So you go volume equals pi r squared times height, which equals pi times 3 squared times 2. So 9 pi times 2 will equal 18 pi inches cubed. All right, hexagonal prism. So that's like this shape. We had it thrown at us earlier. So how do you draw your hexagonal prisms? You just draw 2 hexagons that are congruent, and then connect all these. All right, so here's your hexagonal prism. Base is 4.5 and height is 7. So all you got to do on this, because all prisms are volume equals base height, so volume equals base height. So volume equals 4.5 times 7. So volume equals 7 times 4 is 28. 7 times 5 is 35. So you take the difference. So this one's 31.5, or you get the midpoint, centimeters cubed. Okay. Prism that's 5 feet tall, whose base is a right triangle with leg lengths 3/2 and 9. Okay. I'm trying to make it hard on you, but that's okay. So we got a prism, right triangle. Just draw 2 of them. And then connect the vertices. All right, now let's label the sides. So height is 5, and then the leg lengths are 1.5, or 3/2, and 9. So to get the area of this right triangle, you go 1/2. 9 times 1.5. Okay.
Brianna Salguero, please come to the office.
1/2, 9 times 1.5. 9 times 1 is 9. 9 times 1/2 is 4.5. So that's 1/2, 13.5. Half of 13.5 is going to be 6.5 plus 2. 2.5, 0.25, so 6.75, I think, right? Okay, so this area, which equals the base, is 6.75, and then the height is 5, so you just go volume equals base height. Base is 6.75, height is 5. Let's see if I can do that in my head. So 7 times 5 is 35, right? And you have 0.25 times 5. That's minus 1.25. So that would be 33.75. So volume equals 33.75 cubic feet. Okay, circle with area pi square units is dilating. Use a factor of 5. What is the area of the dilated circle? Okay, so you need to know that area times k squared equals the area prime. So circle with pi, that's A, so A equals pi, is dilated and uses a scale factor of 5. So you just say 5 squared will equal A prime. So the area of the dilated circle is A prime. So A prime is the area of the dilated circle. And that'll just equal 25 pi. So 25 pi square units equals the area of the dilated circle. All right, easy peasy. This took about 20 minutes, so no big deal. Doing it on your own might take a little bit longer, but just try them and then check your answers with the video. So spend like 30 minutes on your own, maybe 40 minutes, 20 minutes on the video. Spend about an hour on homework, no big deal. All right.